Okay, we are going to talk about how you can factor a polynomial based on its graph. And there are a couple things that you want to consider when you are factoring. But the best thing for us to do is just to look at an example. So I'm going to share my screen. Okay, here I have a polynomial. It is degree 4, and the leading coefficient is 1. It's a quartic polynomial. You'll notice here that there are 3 x-intercepts, and I can use the information from these x-intercepts to factor this polynomial. And the reason is because an x-intercept shows me what the zero is for, what a0 is for the function. Now, I'm not talking about the number 0. A 0 for a function is just any number, any real number that when you substitute it or plug it into the function, gives you 0 as your output for y. And that's true about all x-intercepts. So here we have -1. When I plug -1 into my polynomial function, in this case it's f of x, I'm going to get 0 as an output for y. If I plug in 0 into my function, my output will be 0. And if I plug in 2, my output would be 0. It turns out that for any 0, if you know that a number like, say, c is 0, is a 0 for the function, then x minus c has to be a factor, okay? That's a rule. So I can just find the factors of this polynomial by just taking x minus -1 or x plus 1, x minus 0 or x, and x minus 2. So let me go ahead and type that in and let's see what we get. We get x times x plus 1 times x minus 2. These are the factors that I mentioned. Now, surprisingly, the red function that I just typed out does not match the purple function. It's a different function. Why is that? Well, there's something that I didn't consider when I was looking at those zeros, and that is a thing that we call multiplicity. Multiplicity just means how many factors are associated with one zero. So you'll notice here, let me get rid of that red function for a second. Notice here that something different happens. So here's an x-intercept. We're coming down, the curve crosses the x-axis, and also here it crosses the x-axis. But here it doesn't cross the x-axis, it touches the x-axis. In other words, the sign of the function does not change. Every time you cross the x-axis, you're going from positive to negative. So your sign has changed, or you're going from negative to positive. And again, your sign has changed. But when you're below here and you hit the x-axis and then stay below, your sign hasn't changed. You go from negative to negative. That just means that the factor that goes with the 0, in other words, x, is actually x squared, or it could be x to the 4th or x to the 6th. We call that the multiplicity. The power on the factor is called the multiplicity for the 0 that goes with that factor. So in this case, we don't know for sure. Well, we will be able to find out. But at the moment when I look at this, all I can say right now is it has even multiplicity. Because remember, even numbers, when you multiply by x squared, that's always going to be positive. And multiplying by a positive is not going to change your sign. If you multiply by x to the 4th power, again, it's positive. Anything, no matter what x is, if you raise it to an even power, it's going to be positive. The factor is going to be positive, and it's not going to change the sign. That's why the sign did not change as we hit the x-axis. We're still on the same side of the x-axis. We're still negative. So multiplicity is the power on the factor. And when I typed in these numbers or these factors, my graph did not match because I had the wrong multiplicity for x. I had an odd multiplicity. So at the moment, in the way I've described this function here, this has multiplicity 1, this factor has multiplicity 1, and this factor has multiplicity 1. So that means all of these zeros, the graph is going to go through the x-axis. And if you look, that's exactly what happens. The red, you pass through the axis and then through it again and then through it again. And that's because the multiplicity is 1 for each of these factors. But the function that I'm looking for is this function up here. And you can see the degree is 4. So that means you can have up to 3 turning points, but you could have up to 4 intercepts. And we only have 3, so that means there's room for an extra multiplicity. And so I'm going to, because this purple graph touches and then bounces back, I know that the multiplicity here on the x must be 2. Okay, it has to be even, we know that, and there you have it. You see I've matched the graph. Here's my original function, and now I've represented it in factored form. It's the identical function. So that's how we can find the factors of a function and their multiplicities from a graph of a polynomial.